Recently, there was an extraordinary solar storm on the sun that generated a big fire. NASA's Solar Dynamics Observatory revealed a beautiful simulation of this massive explosion of charged plasma. The solar wind reached Earth in April 2022, and on August 9th, following a solar flare, charged particles hit our globe again at 600 kilometers per second. They smashed into Earth's magnetosphere, generating auroras. The northern lights were visible in the U.S. states from Maine to New York, but experts believe this time we were merely fortunate. If a stronger solar storm had impacted the planet instead of a dazzling celestial spectacle, it may have resulted in a calamity. Solar storms have previously displayed their devastating potential at least twice. Now that our sun is once again reaching its maximum activity, the risk of another strong blast of plasma is growing. How did these solar flares affect our planet in the past, and might the peak of our star's activity in 2023 threaten the Earth's destruction? A solar wind is formed when a stream of high-energy particles can no longer be held back by the sun's gravity. Scientists believe the solar wind's blast from enormous black areas on the star called coronal holes. The sun is a huge distance from Earth, and yet coronal mass ejections can reach us in between 2 and 6 days, but the highest energy particles can overcome the same distance in just 2 minutes. Most of them are redirected to the poles by the planet's magnetic field, and only a small number of particles penetrate the atmosphere, emitting rays as they collide with gas molecules, causing the atoms to give off light. But sometimes the sun starts having extremely powerful flares with an energy of about 10 to 25 joules. That's roughly equal to millions of 100 megaton hydrogen bombs. During such a solar storm, plasma rushes through space twice as quickly as normal. It bombards the magnetic field of planet Earth with such energy that charged particles either penetrate or drastically distort it. The outcome is the creation of geomagnetic storms, the greatest of which may cause countless catastrophes. On September 2, 1859, British astronomer Richard Carrington observed a giant solar flare. 18 hours later, one of the strongest geomagnetic storms we know of struck Earth. On that day, telegraphs in all of Europe and North America stopped working and many telegraph poles were burned. People could see the northern lights almost all over the planet. Mankind recovered from the accident relatively quickly, but our civilization wasn't as dependent on electricity as it is now. When another major solar storm struck Earth in March 1989, the entire Canadian province of Quebec plunged into darkness, leaving millions of people without electricity for 12 hours. The solar outbursts that generated this weren't that intense. If the next explosion on the sun exceeds the force of the Carrington event, the most violent geomagnetic storm in recorded history, it would be a disaster. In the past, scientists thought that solar storms of this magnitude didn't occur more often than once a year, but when scientists from the University of Warwick and the British Antarctic Survey analyzed the patterns of solar flares, they discovered that powerful magnetic storms are much more frequent than previously thought. Solar activity has an 11-year cycle. At its apex, the sun exhibits a particularly furious activity, and charged particles are directed towards the Earth. One after another, experts have evaluated the whole inventory of changes in the magnetic field of the Earth, and the findings reveal that the most important bursts of geomagnetic activity correlate with the most violent explosions on the sun. The team of experts discovered 2 categories of the most hazardous catastrophes for the Earth: powerful magnetic superstorms and the most destructive megastorms. The former occur on average every 3 years and damage the health of weather-dependent populations, typically causing headache, blood pressure spikes, increase chronic conditions. Although they don't contribute to serious technological breakdown, megastrong storms are relatively infrequent. Over the previous 150 years, experts have recorded just 6 such instances. Thus, solar storms range on our planet roughly every 25 years, and over the past 2 decades, there have been no megastorms. Scientists predict the next one will happen in the near future. A large, possibly hazardous eruption erupted on the sun in 2012, but the solar wind at that time flew in the other direction and scarcely affected our planet during the next great solar flare. We may be less lucky, although the specific repercussions of such a situation cannot yet be determined. What we know for sure is that vivid auroras will be seen all around the Earth. It's also probable that among them there will be a particular sort of northern light dubbed a significant thermal emission velocity enhancement, or STEV, appearing as purple and less commonly white shimmering ribbons during the August 2022 geomagnetic storm. These auroras were witnessed even in southern Pennsylvania. Scientists don't know the actual nature of this optical phenomenon, although it's commonly observed during solar solar storms. Researchers are certain that Steve isn't only about the light spectacle in the sky. It might be followed by a megastorm that would cause huge disruptions to electrical and aviation systems. Communications, power grid interruptions, and troubles with satellites might even reach the depths of the ocean, devastating undersea internet communications connection. This would lead to a global internet disaster that would last many months or longer. According to some estimations, the harm might possibly amount to billions or perhaps trillions of dollars. If the solar winds of this strength had impacted our globe in 2012, several nations probably wouldn't have completely recovered up to this day. Still, the loss of light laptops and TVs seems like a pittance compared to the majority of other conceivable repercussions like droughts, floods, earthquakes, and tsunamis. These natural calamities are commonly related to solar storms. Observations suggest the largest frequency of earthquakes is found in times of strong and changing solar activity. This might have been one of the causes of the magnitude 9.1 earthquake that occurred in 2004. It also generated a large tsunami in Indonesia, India, Thailand, Bangladesh, the Maldives, Sri Lanka, and Somalia also suffered from this natural catastrophe. Over 283,000 people were killed, another 14,000 are missing, and more than 1 million remain homeless. To offset the terrible repercussions of solar storms, scientists need to establish a warning mechanism. Several spacecraft, notably the Solar and Heliospheric Observatory and the Solar Dynamics Observatory, are investigating the Sun. Their data will help warn us of severe occurrences on the star in time. As the Sun nears its 11-year high of activity, this is very crucial, and only after the stormy activity of the Sun goes down in 2024 can we breathe a sigh of relief. Or can we? Recently, scientists revealed that a massive geomagnetic storm is possible to disregard the 11-year solar activity cycle and abruptly attack the Earth during the Sun's tranquil phase. Scientists have again identified a comparable occurrence in our history. A recent analysis of ancient ice samples beneath Greenland and Antarctica has shown that 9,200 years ago, a solar storm of extraordinary ferocity impacted our planet. So devastating solar storms may strike when we least anticipate them. To avoid being caught off guard, many countries have designated space weather forecasting as a priority in the progress of science. High hopes commented on NASA's Parker Solar Probe. The probe now goes closer to the Sun than any spacecraft did previously, which means it can identify coronal emissions quicker than any other satellite. Data from the Parker Solar Probe will enable scientists to more precisely follow the location of a storm's genesis on the Sun and perhaps pinpoint its path. NASA and the European Space Agency also launched the Solar Orbiter Probe in 2020. It's presently in an elliptical orbit, with the nearest point being 42 million kilometers from the Sun's surface. The probe has already delivered stunning photographs of the star back to Earth. Some of them reveal numerous little light spots and weird black things that are moving and vibrating. Miniature plasma explosions that scientists call campfires are events that presumably enhance the temperature of the star's corona and create solar wind, while other experts are seeking strategies to defend Earth from space. Recently, Japanese innovators from the National Institute for Fusion Science produced an artificial geomagnetic field project. According to geophysicists, the planet's own field has gotten nearly 10 times thinner during the last 150 years. One day, it may not be able to endure the eruptions of highly charged solar particles. Scientists recommend deploying 12 superconducting rings around the globe to safeguard it. Such a structure is considered to be able to increase the geomagnetic field of the planet, but it can only compensate for the 10% that's lost. Maybe we don't need to create any protective structures around the globe since they're already there. NASA's space missions detected a type of artificial energy barrier surrounding the Earth, and it was generated by humans owing to the interaction of extremely low-frequency radio waves with cosmic particles. The human-made barrier was found using Van Allen probes, which are designed to study electrons and ions in space around the Earth. Normally, very low-frequency signals from radio telescopes are transmitted from Earth and used to communicate with submarines deep in the ocean. According to NASA scientists, these signals formed what looks like a huge bubble of energy enveloping the Earth. Its outer layer extends almost exactly to the inner edge of the Van Allen radiation belts. Belts collect charged solar wind particles that later attack the planet's magnetosphere. Researchers say that in the absence of bubbles, the radiation belt boundary would be much closer to Earth than it is now. In the 1960s, when low-frequency communications were less common, the inner boundary of the Van Allen radiation belt was at a much smaller distance from the planet's surface. Do you think this type of shield can protect us from the consequences of the most frightening solar storms, or should we consider other more reliable ways to defend ourselves? Tell us in the comments, and thanks for watching.